In last lecture, we are discussing about three-phase induction motor, right? I'm sharing the screen. In last lecture, we are discussing about three-phase induction motor. Okay. So what we have studied in last lecture? Last lecture we have studied what is three-phase induction motor and what is its working principle. We have studied the working principle of induction motor, right? Or today also I will say that three-phase induction motor is universally used in large size machines, not for small size machines. Small size machines we are using single phase induction motor. Okay, like fan. Fan is a single phase induction motor. As soon as motors are concerned, always we have to use induction motors. Okay? Maximum for home appliances, single phase induction motor. For industries where high power is needed, we use three phase induction. Example, अगर आप day to day life में देखोगे तो you can see in flour mill जो आटे की चक्की होती है, there we are using three phase induction motor. Three phase means three wires are needed. Okay? But our home connection is single phase, right? But in your residence or in your area, always there is a three wire. Some are opting for three phase supply. The three phase supply is also, electricity boards are providing three phase supply also. So it requires three phase induction motor. We will little bit elaborate the induction motor by graphically. How this induction motor looks. Okay? This is the basic diagram of single phase induction motor. More or less from outside you cannot judge it is a single phase induction motor or three phase induction motor. Of course, large size motors are three phase induction motor. Small size are single phase. So this is a picture of single phase induction motor. Okay. As we know that we have a AC supply available, therefore maximum we are using single phase induction. Frequently used motor in the world. Examples are washing machines, refrigerator, all are single phase induction. Okay. Okay. Single phase induction motors are highly reliable and economical also. Why we are saying economical? If you go for DC motors efficiencies are very low, around range of 60-70%. Induction motor efficiency is 80%. Therefore, we are replacing DC machine by induction motor. We won't afford the maintenance of DC machines. DC machines are costly. Induction motor. This is the pictorial diagram of large size three-phase induction motor. Picture of large size three-phase induction motor. I hope this picture is visible to everybody. You can see that motor is in the center and that box is green color box is housing. Company name is Siemens. With these big companies, Siemens, like companies will manufacture are manufacturing this three-phase induction motor. And these are used on industrial application like rolling mill or cutting mill, where heavy load is there. 50 kilowatt, 100 kilowatt, or 10 horsepower, 20 horsepower, 50 horsepower, there we use three-phase induction. This you can see the components of induction motor, that is very important. You can see the components of induction motor. You can see this is the stator. Okay? This is stator. Okay? Stator mein you can see that there is a winding. This is your winding. Windings are mounted on the slots. These are slots. ये देखो, ये यहाँ पे आपको slots दिखेंगे, छोटे छोटे slots. Slots windings are sandwiched between these slots through insulation. You can say white here, white. You can see there white insulation is also there. So three-phase winding, slots are there. The stator construction is like this. Now look on rotor. This is the rotating part of the machine. ये देखो, ये आपकी यहाँ पे rotor bars होते हैं इसके अंदर. Then you can see we have discussed about end bells. Well, switch is there, centrifugal switch is there, which can turn on. This is the rotor, main part of the machine, rotor. This is bearings. Through bearings, you can communicate. ठीक है ना? Bearings are very important. Bearings में वो घूमता है, ठीक है? Anybody having any questions or doubts, so they can ask. आप पूछ सकते हैं. This is also a stator of large induction motors. This is not a small size. This is very large size. बड़ी कंपनियां Siemens का make है. Courtesy is given Siemens. Siemens will produce are the manufacturer of this large size motor. ठीक है. Stator view also you can see. This is also a stator view. Different types of stators are there. Now you are in position to visualize the slots. ये slots होते हैं. Now you can visualize the slots. Slot scopes. These are the slots. ये आपके slots हैं, ठीक है. I hope so. Slots is visible to everybody. These are the stampings. Stator का stampings. One layer of stator. ऐसा पट्टी जोड़ के हम thin stampings करते हैं ना. Why we go for stampings? In order to reduce the eddy current loss. These are the stampings of stator which are merged together and one slot is built. The elements of laminated iron core are punched from a silicon iron sheet. Silicon iron sheets is core, stator core. Stator core is made up of thin lamination. Stator core is made up of thin lamination, which is called as stamping. The sheet has 36 slots and 4 holes for assembly of the iron core. These are the slots. We have already solved the numerical of synchronous machine. Synchronous machine stator construction is exactly same as induction motor. तो अब ये देख सकते हो ऐसे slots होते हैं. These are the slots where windings are mounted. ठीक है. ये आपको थोड़ा सब व्यू दिख रहा है. Of course, single phase or three phase. Like three phase, so we have 3 windings. Displacement is spaced by 120 degree. So exactly you have to know that the iron core sheet is made up of, stator is made up of thin sheets, laminated sheets, like this. In this circuit, rotor is also there, stator is also there. And in midway there is a, in the midway there is a gap that is called as, this is the gap, small gap, air gap.
Recording
right? Right? Anybody having any doubt, they can ask. Who is talking between class? Just mute your phone.
ते चांगलं आहे.
जबरदस्त आहे. इव्हन सर पण नाही म्हणू शकणार की अरे नाही मेरी इधर ये प्रॉब्लेम था. सगळे मुलं पाहू शकतात तिथे यार उल्लू बनवत आहे. इतकं जबरदस्त आहे आणि शॉर्टकट की ठेवलेलं खूप शॉर्टकट की
म्हणजे जेव्हा क्वेश्चन विचारतात ना एखाद्याला तेव्हाच त्यांना नेटवर यावं. सर मला डिस्कनेक्ट हो गया था सर.
शिवानी, हेलो, उनको बोलो ना राव सर से मिलना है, बोलना 2 मिनट के राव सर या तुम। तो गेट पे रख दो। हाँ, it is visible. Stator and rotor magnetic field, right? So there is a just this is air gap. Okay, red color I am showing. This is the air gap between stator and rotor rotates just in the center of the stator. Okay, by a distance separated by a air gap, right? Then you can see squirrel cage rotor. This rotor, we have studied 2 types of rotor, squirrel cage rotor and face wound rotor. Squirrel cage rotor, the rotor has a laminated iron core with slots and it's mounted on shaft. Okay. Aluminum bars are molded in the slot. We have already discussed in last class. In rotor, there is a bars, rods. You can say rods or bars are mounted in a slot. And the bars are short circuited with 2 end rings. The end part is short circuited. The bars are slanted on the small rotor to reduce the audible noise. मैं आपको ये bars दिखाता हूँ. This is like the construction of rotor. Just try to understand this construction. How is the construction of rotor? ये construction को आप समझने की कोशिश करो. कि this is made of aluminum bars. These are aluminum bars or copper bars. ठीक है, ये copper bars rods होते हैं. And this is end ring. Of course, this end ring is also metallic. Metal का ही होता है end rings. And through these end rings, the ends are short circuited. The rotor winding is short circuited through end rings. End में end rings, through end rings, rotor bars are short circuited. And second thing, one statement is given, rotor bars are slightly skewed. Slightly skewed, or we call it as slanted. Slanted होता है वो थोड़ा सा slightly. Why it is slanted? Because slightly slanted होता है या skewed भी बोलते हैं. Here it is written, slots are bars. The bars are slanted on a small rotor to reduce the audible noise. Noise को reduce करने के लिए slant करते हो. ठीक है. हेलो, ठीक है, मैं ले लूंगा, आपका टेंशन मत लो, मैं तुम्हें व्हाट्सएप कर दूंगा. ठीक है, is it clear to everybody? It is slightly slanted. Okay. In order to reduce noise signal or humming, उसको reduce करने के लिए हम लोग थोड़ा सा rotor bars are skewed or tilted. Somewhat it is tilted or slightly थोड़ा tilt रहता है, not straight रहते हैं. So now you are understanding how exactly rotor is constructed. Now you are in position to understand how rotor is exactly constructed rotor, how rotor looks. ये देखो ये bars है, these are the end rings, ठीक है, and it's short circuited end rings, ठीक है. Now we'll see this picture. You can see in this picture you can clearly see how rotor exactly looks. So this is the ring and rings. This is also ring and rings through which these bars are short circuited. You can see ये जो आपको white color का दिख रहा है ना, this is insulation. And the bars are not short circuited directly. They are short circuited at the end. In the end, it is short circuited. Okay? This is called as fan. This is called as shaft. Fan भी लगा हुआ है तो fan blades बोला दिया. This is ring. And this bar is aluminum bar is written. It can be not necessary aluminum bar. Copper bars can be used. We want a good conductor of electricity for windings. So copper bar or aluminum bar both are used. ठीक है. Core. Here the sheets are there. Core is made of thin laminated iron core. Shaft is here. Anybody having any confusion in construction, they can ask. Okay. So it is clear. Shaft is there. Bars are there. They are tilted to reduce the noise or humming noise. There is a humming sound between magnetic because of magnetic field. So that can be reduced by a tilting a rod. Rod is slightly skewed. Next is phase wound rotor. While studying the construction of three-phase induction motor, we have talked about two types of three-phase induction motor. Like synchronous machine, we have talked salient pole and non-salient pole. But in case of induction motor, rotor is different. There is no DC supply. 3 windings are there. So rotor are of 2 types. One is cage type, squirrel cage type, and second one is phase wound type or slip ring type we call it. So second rotor is wound rotor. Okay? In wound rotor, there is no bars, there is a windings. 3-phase winding. Okay? So you can study here. Most motor use the square cage rotor because of robust and maintenance free construction. However, large old motors use a wound rotor with 3-phase winding placed on rotor slots. Okay? In the last case, what we have studied, squirrel cage, only bars are there, but in phase wound motor, 3-phase winding is in the rotor. The ends of the windings are connected through 3 slip rings. ठीक है, हम देखेंगे कि वाइंडिंग की जो 3 वायर है वो थ्रू स्लिप रिंग से कनेक्टेड होते हैं. Resistors of power supplies are connected to the slip ring through brushes for reduction of starting current and speed current. इसका एक डिफरेंट एडवांटेज है. Like you can connect the outer world to the rotor. In case of phase wound rotor, phase wound rotor के 3 कनेक्शन, जैसे in case of DC motor, brushes are there. Through brushes, contact brushes, we can connect, we can take DC power or we can give DC power. Similarly, in case of 3-phase induction motor or phase wound type rotor, there are 3 slip rings, R phase, Y phase and B phase. So you can connect resistances or you can give external supply to rotor also. You can give external supply to rotor also for speed control or controlling starting current. So 3-phase induction motor mein we are going to study why starters are needed, starting of 3-phase induction motor. In order to reduce the starting current, you need a 3-phase induction motor. You need a phase wound rotor where connection is there. There you can connect the. You can see the picture view of large size induction motor. It's a rotor. Okay? Large size induction motor. Of course, but see, it is mentioned, reference is given that it is taken from Siemens. Okay? Operating principle of three-phase induction motor we have already studied. So you can see this the connection diagram of two-pole induction motor with squirrel cage. You can see here clearly. Up here clearly, you can see it clearly. Here, these are the slots. In the slot, stator winding is there. This is rotor, and this is rotor slots where rotor bars are there, squirrel cage bars are there. So depending upon number of slots, each phase has 2 into 3, 6 slots. Because total number of slots are 24. So, sorry, 8. Total number of slots are 18. Therefore, we have given each pair divided into 2 into 3, 6 slots. The phase are shifted by 120 degree. Each phase is shifted by 120 degree. Okay, A, B, C is given. Okay. This is A plus winding, it is minus winding, B, B plus, like this. The squirrel cage rotors had short circuited bars. And में वो rotor windings is short circuited, not stator winding. The stator three-phase windings can also be connected in delta configuration. The stator winding is three-phase winding. It can be connected in star as well as delta. In general practice, motors are connected in delta. Synchronous machine is always connected in star. But three-phase induction motors are generally connected in delta for high power applications. Next, operating principle we have already discussed. अगर आपको in 2 lines, if I want to explain operating principle, just I want to explain. We have to give a three-phase supply to three-phase winding. Rotating magnetic field is produced. Rotating magnetic field is produced which rotates at synchronous speed. Once the rotating magnetic field is produced, it cuts the rotor conductors. Therefore, as per Faraday's law, EMF is induced in the rotor conductor. EMF is induced and rotor conductor is short circuited through and rings. Some rings are there. Due to which rotor circuit is short circuited. Therefore, current flows in the rotor conductor. Now we have a current carrying rotor conductor. Current carrying rotor conductor placed in a stator magnetic field, or you can say interaction of rotor current. Interaction of rotor current and stator magnetic field gives rise to a force or torque, and motor principle is applied and the motor start rotating. For studying any motor, you should know the motor principle. To run any motor, what you need? Rotor is moving. So rotor is moving means you need a conductor, rotor conductor, having a current carrying rotor conductor placed in a stator magnetic field. Experience the force, and this force gives rise to torque. And developed, motor start rotating. There is no torque in transformer. Now you can say there is a three-phase winding in transformer. Why transformer is not rotating? There is no two opposite force. Getting my point? There is no two opposite force. There is no two opposite force to develop a torque. Two anti-parallel opposite force develops a torque in case of transformer. Therefore, transformer is not rotating. Here what is happening? Just I will show through annotation. If the force acting in this is this direction, then in the reverse is negative force, and this force will act in this direction. So because of these two forces, torque is developed, and torque is developed, therefore rotor starts rotating. This is not with the case of transformer. You will say there is a three-phase primary winding of transformer and there is three-phase secondary winding of transformer. Why transformer is not rotating? So there is no force and no torque in case of transformer. Okay. I hope so everybody understood this. We have already studied operating principle. We have already studied this operating principle. Faraday's law, all of you, everybody knows this. Voltage is induced in the conductor that moves perpendicular to the magnetic field. Magnetic field is rotating, which is striking the conductor, rotor conductors. Therefore, EMF is induced in the. This equation we will see later on. So, force, we are always talking about force. The force acting in a magnetic field is given by BIL. We have already studied in 12th also. You need a magnetic field, length of conductor, and current. Or you can say current carrying conductor placed in a magnetic field experience a force. Without current carrying conductor, force will not be experienced. Okay, here you can see the clear picture. How force will be developed or force will be applied on the rotor conductor. Okay? This is rotor bars are there and force will be developed. Actually, what happens when you give a three-phase supply to three-phase winding, a rotating magnetic field is produced. This rotating magnetic field cuts the rotor conductor and EMF is induced, generator principle. EMF is induced in the rotor conductor. Because of EMF induced in the rotor conductor and rotor circuit is short circuited through end rings, current flows in the rotor conductors. Once the current started flowing, this is shown here. Once the current started flowing, you can see this is current IR. Current started flowing. Then current carrying rotor conductor placed in a magnetic field experience a force. Force will come into picture. One positive force in this direction, exactly its opposite conductor will affect a negative force, two anti-parallel forces. Because of these two anti-parallel forces, torque is developed and motor starts rotating. Okay? We have already studied this rotating and motor will rotate in the same direction. Okay, anybody having any doubt, they can discuss the equations. What are the torque equations, force equations, characteristics? We'll discuss in next class in board. Here it is. Now we are interested in discussing the characteristics, equivalent circuit. ये सब हमें discuss करना है. So we'll discuss in next class. Okay. तो equivalent circuit को मैं एक बार बता देता हूँ आपको. What will be the equivalent circuit of three-phase induction motor? The equivalent circuit of three-phase induction motor is exactly same as transformer. Stator is primary winding, rotor is secondary winding. We have already, or I taught you in second year in machine one's equivalent circuit of transformer. So primary winding of induction motor is stator, three-phase supply we are giving, and secondary winding of induction motor is rotor. Therefore, the equivalent circuit of transformer is equivalent circuit of induction motor is exactly same as transformer. Of course, here, since the rotor is short circuited, you have to show this rotor circuit short circuited. But in case of transformer, we are connecting a mechanical load. Here we are not connecting the mechanical load. We'll see in next class in board mechanical equivalent load, how to connect the mechanical equivalent. Okay, the equivalent circuit of induction motor, then we have to draw the phasor diagram of induction motor. This we are going to study in next class. Okay, these equations I will derive you in class board. What are the important equations? वो हम देखेंगे. ठीक है, what is slip speed? ठीक है, this we can study. Anybody having any doubt or queries, they can ask. किसी को कोई doubt or queries है तो they can ask. Anybody having any doubt or queries? Of course, induction motor is a very big topic. It is not easy to study in one day. Of course, slowly we have to do the analysis part. Study part you can go through YouTube's also. YouTube video lectures also. I am going to